Hello, in today's video we're covering section 3 of our first unit called More with Angles and Pairs of Angles. To start our unit off today we have this angle addition postulate which says if S is in the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR is equal to the measure of angle PQR. Now I've already gone ahead and pre-drawn what this postulate is saying. So we have this angle PQR with S somewhere in the middle of it. So they're saying that if I take the measurement of angle PQS, which is this angle here, this angle PQS, and I add it to the measure of angle SQR, which we'll mark there, if I add those two angles together, that gives me this full angle, PQR. Alright. So now, let's take a look at an example. The measure of angle DEG is 115 degrees, and the measure of angle DEF is 48 degrees. Find the measure of angle FEG. Okay, so I have that DEG is 115 degrees, so let's go ahead and mark that. I'm going to draw an arc going over the whole thing. That is 115 degrees. And then it says DEF is 48 degrees. So that's this interior angle there. That's 48 degrees. And we're looking for angle FEG. All right, so by my angle addition postulate, then I can say when referring to this angle, that angle DEF plus angle FEG is equal to angle DEG by the angle addition postulate. So now I'm going to go ahead and I'm going to plug in my numbers for this example. So for DEF, that is 48 degrees. FEG is unknown, so we will leave that as an X. And angle DEG is 115 degrees. Now what you might have already noticed, you can just say, as we're going to do in our algebra here, that if we do 115 degrees minus 48, because we're subtracting 48 on both sides, then that leaves me with X, which is equal to angle FEG, which is equal to 67 degrees. And this is our solution right there. Now you may have already noticed that 115 minus 48 over here. For this example, I wanted to show our work in the postulate, so that is why I'm setting it up like that. If I'm asking you to use the angle addition postulate, you need to write it in that form. If I'm just asking you to find the missing angle, then you can go ahead and just write 115 minus 48. All right, let's go ahead and look at a couple more examples here. All right, K is in the interior of angle LMN. If the measure of angle LMK is equal to 52 degrees and the measure of angle KMN is equal to 12 degrees, find the measure of angle LMN. All right, so I've already drawn a picture again. I have angle LMN with some K in the middle, and I don't know what LMN, the whole angle, equals, but I do know that the interior angles are measured 52 and 12 degrees. So I'm going to go ahead and label those. LMK I'm going to label as 52 degrees, and KMN is 12 degrees. Now that's obviously not drawn to scale. Just do the best you can and make sure you label it. Alright, so if I'm trying to find the measure of angle LMN by the angle addition postulate, I can just add those two angle measures together. So 52 plus 12 is equal to 64. So the measure of angle LMN is equal to 64 degrees. Alright, this next problem is very similar, but it gets a little more complex because now we have these algebraic expressions as our measurements. I have BD bisects angle ABC, and the measure of angle ABD is equal to 1/2 y plus 10. If the measure of angle DBC is equal to y plus 4, find the measure of angle ABC. All right, so our key words in here are right here. BD bisects angle ABC. That means that angle ABD and angle DBC are congruent. Because these two angles are congruent, then to solve for my y, I have to set these two angles equal to each other because they are congruent. So I have 1/2 y plus 10 is equal to y plus 4. I'm going to go ahead and combine my like terms by moving my terms around. I'm going to start by subtracting my 1/2 y from both sides. And in the same movement, I'm actually going to go ahead and subtract 4 from both sides. So 10 minus 4 is 6. Y minus 1/2 y is 1/2 y. That leaves me with 6 is equal to 1/2 y. I'm going to go ahead and get rid of this fraction by multiplying both sides by 2. That leaves me with y is equal to 12. All right, so now that I have y, I can plug that into either equation. It doesn't matter which one because they are congruent, so it'll give you the same answer. So I'm going to start with y plus 4, which is equal to my y is 12, so 12 plus 4, which is equal to 16. All right, so both angle ABD and angle DBC are equal to 16 degrees. Because we have two equal angles, you can either say, okay, well, the measure of angle ABC will then be equal to 16 plus 16 because there's two of them, or you could just do 16 times 2, either is fine. Either way, you end up with 32 degrees. 16 plus 16 is equal to 32 degrees, and that is your final answer. All right, let's go ahead and switch to the next page. Now that we've worked with a few examples of angles and the angle addition postulate, we have a few more terms to learn here, and all of these have to do with pairs of angles. So if I have adjacent angles, then I have two angles in the same plane with a common vertex and a common side. So an example of adjacent angles would be if I were to have, kind of like in the previous example, you have this one big angle, and inside that angle is some ray, which creates two angles. So these two angles would be considered adjacent angles because they're in the same plane, they have a common vertex and a common side, which is this angle there, or that ray there. That's the common side. So if we were to mark these as angle 1 and angle 2, then I could say that angle 1 and angle 2 are adjacent. All right. Next we have complementary angles. Complementary angles are angles where you have two sides whose measures have a sum of 90 degrees. So your complementary angles can be adjacent angles, but they don't actually have to be connected like adjacent angles are. You could just have two separate angles. So I'm going to go ahead and draw my example where I have two separate angles so that you can see it that way, but they often will be adjacent as well. So if I were to draw this angle here and this angle here, and I were to tell you that this is angle A and this is angle B. Okay, so if I were to tell you that angle A is equal to, let's say that that is 20 degrees. And angle B is equal to 70 degrees. Then if I were to add them together, 70 plus 20 is equal to 90. Then I could say that angle A and angle B are complementary. All right. Next, I have supplementary angles. Supplementary angles are two angles whose measures have a sum of 180 degrees. All right, so just like this previous example with complementary angles, they can be separate or they could be together. I'm going to go ahead and draw them separate again. Notice the difference. Complementary, 90 degrees. Supplementary, 180 degrees. So our two angles should add up to 180 degrees. So let's go ahead and draw a picture here. If I have this angle here, and I have this angle here, all right, I'm going to call the first angle angle C, and the second angle angle D. And I'm going to say that our angle C is equal to, let's call that 100 degrees. So if this is 100 degrees, and this would be 80 degrees, 100 plus 80 is equal to 180. So then I can say that angle C and angle D are supplementary. All right, so now let's go ahead and look at an example. All right, our first example says, an angle measures 51 degrees. Find its supplement, find its complement. All right, I'm going to go ahead and draw a line down the middle here, and I'm going to find its supplement on the left and its complement on the right. I'm going to just go ahead and label that a second. All right, so supplementary angles are two angles that add up to 180 degrees. So if you have one angle, that other angle that completes that 180 degree sum, that's what you call the supplement. So if I have a 51 degree angle and I need them to add up to 180 degrees, I'm going to go ahead and subtract that angle measurement from 180 degrees. 180 minus 51, we can't go from the 0, so we're going to borrow. 10 minus 1 is 9, 7 minus 5 is 2, 1 minus 0 is 1. So the supplement is 129 degrees. And its complement, complementary angles are two angles that add up to 90 degrees. So a complement needs to complete the 90 degree angle measurement. So I have 90 degrees minus 51 degrees. Again, we're going to borrow. 10 minus 1 is 9, 8 minus 5 is 3, which means that our complement is 39 degrees. All right, our second example. An angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the angle. All right, so if our angle is 10 more than 3 times the measure of its complement, the complement is the first thing we're going to work with here, because I'm recognizing that that means that I have to have two angles. I'm going to call them X and Y. So X and Y should add up to 90 degrees because they're complementary. If one of my angles is 10 more than 3 times the measure of its complement, then one of these angles needs to be 10 more than 3 times the other. So I'm going to say that X, our angle X, is equal to 10 more than, means addition, 10 plus 3 times the measure of its complement. Well, if we're finding X, then its complement is Y. So then it's 3 times angle Y. 3 times angle Y. I'm going to go ahead and take the angle measurement marks out of there to clear this up a little bit. So I have 3 times y plus 10. All right, now that I know what angle x is equal to, I can plug this into my formula here. So I have 10 plus 3y plus y is equal to 90 degrees. I'm going to go ahead and combine like terms. 3y plus y is equal to 4y. So I have 10 plus 4y is equal to 90. I'm going to get my y by itself. I'm first going to remove this 10 because it's easiest to move as there is no coefficient. Sorry, there's no variable. 10 is the coefficient. So I'm going to subtract 10 from both sides. That leaves me with 4y is equal to 80. I need y by itself, so I'm going to divide both sides by 4. That leaves me with y, angle y, is equal to 80 divided by 4, which is 20. 20 degrees, that's one of my angles. And I need to find the measure of the angle, which is x. So I have two options here. I either take my value for y and I plug it into this equation. 3 times 20 is 60, plus 10 is 70. Or I can say these are complementary angles. So if I do 90 minus 70, sorry, that's the answer. 90 minus 20, that is equal to 70 degrees. So angle x must equal 70 degrees. If you wanted to check your answer, I would do one of two things. You're either going to take, if you did 90 minus 20, you're going to take your answer and you're going to make sure that that checks out if you plugged in both x and y over here. And if the option you chose was to plug y into this equation, then you're going to go ahead and you're going to solve for that x, and then you're going to say, does my answer plus my y equal 90 degrees? If it does, you're in the clear, it checks out, you can move on. All right, let's go ahead and move on to the next page where we have one last vocabulary word and one last theorem here in this lesson. Our vocabulary word is vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. So I have these intersecting lines here, and when they intersect, it creates this bow tie pattern in both directions, and the opposite angles, 1 to 3 and 2 to 4, are what we call vertical angles. Vertical angles do not mean that they are up and down from each other. They can be, but it really means that they are across the intersection from each other. So if you were to think of this as if you were going for a walk and you came to an intersection and you were walking and you came here, you can't go straight from 3 to 1 across the intersection. You can only go 3 to 2, 2 to 1. So it's the opposite street corner that you're not allowed to just walk straight to. Those corners are the vertical angles. All right. So along with our vertical angles, we have the vertical angles theorem, which says if two angles are vertical, then they are congruent. I'm going to go ahead and use the image in our box above here, and it says that if two angles are vertical, then they are congruent, which means, if we were to drop this down, that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. All right, let's go ahead and look at some examples. Identify each pair of angles as vertical, supplementary, complementary, or none of the above. Starting with number 1 here, I have 120 degrees and I have 60 degrees. They're adjacent. If I were to add those two together, 120 plus 60 is equal to 180. Because they add up to 180 degrees, I know that they are supplementary. So 1 is supplementary. 2, I have 75 degrees across from 75 degrees. They are congruent angles across from an intersection, which means that I'm working with vertical angles. They are neither complementary nor supplementary. 75 plus 75 does not equal 180 degrees. It does, however, equal 150 degrees, but that does not apply to anything other than vertical here. All right, number 3, we have a 30-degree angle and a 60-degree angle. If I were to add those two things together, 60 plus 30 is equal to 90. Because they add up to 90 degrees, it's not supplementary, they're not vertical, so those have to be complementary angles, which if you remember from the definition, two angles that add up to 90 degrees, that's what we have here. Number 4, I have 60 degrees and 40 degrees. If I add 60 and 40, that adds up to 100 degrees. 100 degrees is not supplementary, it's not complementary. These angles are not vertical angles, so these are none of the above. I'm going to go ahead and just write N/A. If you didn't know, that stands for not applicable. None of those answers, vertical, supplementary, or complementary, apply. It is none of the above. All right, let's go ahead and move on to our next page here. And as I'm getting to this page, I'm realizing I said that we were finished with our definitions for this unit, but I forgot this one. We also have linear pairs. Linear pairs are two adjacent angles whose non-common sides are opposite rays. So what that looks like is if we were to draw, let's draw a straight angle, which is another word for a line, two opposite rays. It's a straight angle. And these are two adjacent angles, so if I were to shoot off another angle here and call these angle 1 and angle 2, then I could say that angle 1 and angle 2 are a linear pair because they're two adjacent angles that have, well, whose non-common sides are opposite rays. So angle 1 and angle 2 are, or rather than are, we'll say form a linear pair. Form a linear pair. All right. We also have this linear pair postulate, which says if two angles form a linear pair, then they are supplementary. All right, we're going to go ahead and just use the image from above again. So if I were to drop that example down, then I would say that in our linear pair, angle 1 plus angle 2 is equal to 180 degrees. So linear pairs are two adjacent angles whose non-common sides are opposite rays, and they add up to 180 degrees. So it has to meet all of those requirements, and if it is a linear pair, it will meet all those requirements every single time. All right, let's look at an example here. Solve for x and find the measures of the angles. So I have these two angles here, 4x plus 52 and 3x plus 37. I'm noticing that these are along a straight line, which means that they form a linear pair because they are adjacent angles. So if they form a linear pair, then to solve this for both x and the angle measures, I need to plug these into my supplementary angle formula, which is 4x plus 52, that's one angle, plus the second angle, which is 3x plus 37, is equal to 180 degrees because they're supplementary. I'm going to go ahead and zoom in for the steps here. I'm going to go ahead and start by combining like terms. 4x plus 3x is 7x, plus 52 plus 37 is equal to 89, which is equal to 180 degrees. I'm going to go ahead and subtract 89 from both sides, working towards getting x by itself. That leaves me with 7x on the left. 89 degrees subtracted from 180 Well, 180 minus 80 is 100 degrees. 100 minus 9 is equal to 91, so this is equal to 91. If I were to divide both sides by 7, that leaves me with x by itself on the left. 91 divided by 7 is 13. Now I'm going to go ahead and, well, first I'm going to box that because that is one of my answers. My job was to solve for x, and now I also want to find the measures of both angles. So I'm going to go ahead and plug 13 in for both angles. So I have 4x plus 52 is equal to 4 times 13 plus 52. All right. 4 times 13 plus 52, if we were to break down this in our head here, 4 times 3 is 12, 4 times 10 is 40, 40 plus 12 is 52, 52 plus 52 is equal to 104, so this is equal to 104 degrees, and there's one answer. And our other angle was 3x plus 37, which is equal to 3 times 13 plus 37. All right. 3 times 13 is equal to 39. 39 plus 37 is equal to 76. So this is equal to 76 degrees. And now we have found all three pieces. We found each angle measure, and we found the measure of x. Alright, this is where we're going to go ahead and stop for today. We'll pick back up in our next video lesson, which will cover transversals and the converses of transversals.